In this video, we'll discuss the difference between extrapolated and interpolated results, how they're reported, why this happens, and how they should be handled. Interpolation means calculating an unknown concentration from a response that lies within the range of the measured standards. Extrapolation means estimating a concentration from a response that lies outside the range of the measured standards. This could be above the top standard or below the lowest standard. Because the result is outside the experimentally validated range of the assay, extrapolated values should be treated with caution. In some cases, data analysis software such as MyAssays might report an extrapolated concentration with a warning, while in other cases it does not calculate a concentration and instead reports above or below the curve. For samples outside the standard range, the recommended analytical approach is to rerun the sample at an appropriate dilution or concentration so that the corrected response falls within the standard range. For samples above the highest standard, the usual recommendation is to dilute the sample and rerun it so that the response falls within the calibrated range. For samples below the lowest standard, the result may be repeated for confirmation and is generally reported as below the lower limit of quantification or below the lowest standard, unless the assay protocol provides a validated approach for handling low-end extrapolation. If it's not possible to rerun a sample, then any calculated value outside the standard range should be reported clearly as an extrapolated estimate. Alternatively, depending on the laboratory's reporting requirements, the sample may be reported as greater than the highest standard concentration or below the lowest standard concentration, rather than assigning a numerical value. Whether or not MyAssays can calculate an extrapolated value depends on several factors: the fit method, the shape of the curve, the response value, and the analysis rules applied. Let's take a look at a couple of examples. I have opened mycurvefit.com with an example dataset plotted using a 4PL fit. I'm using myCurveFit for these examples because it allows us to easily try different fit methods and quickly see the results. I also have 3 responses I've added to my predict table. The first falls within the range of the standards. You can see it plotted on the chart with this blue triangle. The second is outside the range of my standards, but within the range of the curve limits. For a sigmoidal curve like 4PL or 5PL, the curve limits are represented by the A and D parameters. For samples with responses between the A and D parameters, a concentration result can be calculated. This point is represented by the blue triangle to the far right of the chart. The third prediction is far outside our standard range and does not appear on the chart as it's incalculable for this curve fit. It's reported as NaN since it's outside the limits of the curve. Now let's look at how different fit methods handle this data set and the resulting prediction points. First, let's look at another sigmoidal fit, the 5PL fit. Applying this fit method shows that we're unable to extrapolate our second prediction point, the one slightly outside the range of the standards. Applying a polynomial fit, such as a cubic regression, shows extrapolation for our second prediction. However, you can see unstable behavior outside the range of the standards. For example, this curve features a turning point where any samples with response values in this range could return 2 possible concentration results. Next, let's look at a cubic spline. This time, both prediction points return calculated concentration values. However, you can see this curve features 2 turning points, showing unstable behavior outside the standard range. Now let's compare this with a linear regression fit. Up to now, we've displayed the data on semilog axes, which is commonly used for dose-response curves because concentration usually spans several orders of magnitude. However, changing the x-axis only affects how the data are displayed. It does not make a sigmoidal relationship linear. To demonstrate a standard linear regression, I'll set the fit method to linear regression and change the x-axis display to linear so that we can see the resulting straight line. We can see the accuracy of this curve is not as good as the 4PL. Specifically, we can see the line is not accurate around the plateaus. However, because of the nature of the linear regression, it's possible to extrapolate indefinitely even if the fit isn't accurate. If I add another prediction point far outside the range of my standards, you can see the concentration is extrapolated, but I would not consider this a reliable result. Linear regression is not generally suitable for sigmoidal dose-response curves because these data are intrinsically nonlinear. Responses typically have a lower plateau, a steep concentration-dependent transition region, and an upper plateau caused by biological or assay saturation. And as we can see, the linear regression will extrapolate unrealistically beyond the observed data, because a line continues indefinitely, whereas real biological responses approach limits. Therefore, linear regression may only be defensible over a predefined, valid linear working range. For full sigmoidal dose-response analysis, a 4PL or 5PL nonlinear regression model is more appropriate. In addition to different fit methods handling the data differently, adding a weighting model can bias the curve to pass through certain standard points and can change the shape of the curve and the curve limits. Let's go back to our first fit, the 4PL, and I'll also change the x-axis back to a logarithmic scale. You'll recall that with no weighting applied, the third prediction point could not be extrapolated as the value is outside the curve limits. Our first response interpolates a concentration of 58.448, and our second response extrapolates a concentration of 800.25. Let's apply a weighting model, 1 over x squared. So now our third prediction does show an extrapolated concentration. Looking back at the predict table, let's review the calculated concentrations for each of our samples. The first interpolated result is quite similar, 53. The second extrapolated result is pretty different though, 800.25 compared to 351.7. So this begs the question, when is it okay to extrapolate data, and what is a usable extrapolation? Extrapolation differs for each fit method. As we've previously seen with the linear regression, it is mathematically possible to extrapolate indefinitely because the fitted line continues beyond the lowest and highest standards. However, this does not mean the extrapolated values are analytically reliable. Extrapolation from a linear model should be used with care. We recommend defining an appropriate acceptable extrapolation limit. For example, allowing extrapolation only within a defined percentage beyond the standard range. For legacy fit methods, like cubic regression, polynomial regression, or cubic spline, extrapolation is not recommended. These fit methods may have turning points or display unstable behavior outside the fitted standard range. A response just outside the standard range may not map reliably to a meaningful concentration, and in some cases, the fitted curve may turn back on itself. This can make extrapolated concentrations misleading or impossible to calculate. For 4 and 5PL curves, extrapolation may be possible within the usable range of the fitted curve. However, accuracy reduces as the response approaches the upper or lower asymptote. Near an asymptote, large changes in concentration may produce only a very small change in response. This makes the calculated concentration increasingly sensitive to small measurement errors. For this reason, extrapolation near the asymptotes of the curve should be restricted and clearly flagged. So what is a usable extrapolation? A usable extrapolation range is a controlled region outside the standard range where the software is allowed to calculate an estimated value, subject to defined limits. For example, a laboratory may choose to allow extrapolation only up to 15% beyond the highest or lowest calibrator response. Extrapolation should not be open-ended. It should be controlled by rules, warnings, and validation criteria. With MyAssays Desktop and MyAssays2.com, extrapolation can be supported in a controlled way. Rules can be added to define when extrapolation is allowed, highlighted, validated, or blocked. For example, we could allow extrapolation only when the response is within a defined limit, such as 15% beyond the standard range. Results within this limit could be calculated but flagged with a warning. Results beyond this limit could be blocked or reported as above or below the assay range. Let's take a look at an example protocol on MyAssays2.com with this criteria applied. In this example protocol, any samples with response values outside the range of the standards are highlighted in yellow. Samples with responses within 15% of the standard range will return concentration results and appear in red text. Samples with response values outside the allowed 15% range will report greater than limit or less than limit. I'll use the default settings for this assay. However, we could move through these tabs to customize the assay for our specific assay run. Select the report format. In this case, I'll select Excel and press Calculate to calculate our results. On our report, you can see these extrapolation rules applied. Unknowns 1, 2, and 4 are highlighted in yellow. Looking at the blank corrected values, we can see unknown 1 has values of 0.146 and 0.145. These are lower than the values of the lowest standard, standard 1, 0.191 and 0.198. Unknown 2 has blank corrected values 2.585 and 2.583, which are higher than the highest standard, standard 6, which has values of 1.621 and 1.620. Unknown 4 also has blank corrected values higher than the highest standard. The concentration values are reported as less than limit and greater than limit for unknowns 1 and 2, as the response values are more than 15% outside the range of the standards. Unknown 3 is within the range of the standards and returns an interpolated concentration, so no additional formatting is applied. Unknown 4 is outside the range of the standards, but within the 15% extrapolation limit, so the concentration result appears in red text. This protocol illustrates how these rules can help users avoid reporting unreliable extrapolated concentrations, while still allowing controlled handling of borderline out-of-range samples. In summary, where possible, rerun out-of-range samples at an appropriate dilution or concentration so that the response falls within the standard range. Where rerunning is not possible, report any extrapolated value as an extrapolated estimate, or report the result as above or below the validated standard range, depending on the laboratory's reporting policy. Avoid unrestricted extrapolation, especially with spline, cubic regression, and polynomial fits, and be sure to define acceptable extrapolation limits where extrapolation is permitted. If you have any questions about how to handle extrapolated sample results for your assay, contact us at support@myassays.com.